Hello everyone, today I'll be discussing the program 4 where it is to simulate an Ethernet LAN using N nodes, and we have to set multiple traffic nodes, and then by using the X graph we'll be plotting the congestion window for different source and the destinations. This is the program 4. So first is about the Ethernet LAN. The Ethernet, which is IEEE 802.3 standard, comprises several wiring and signaling variants of the OSI physical layer. Here there are different Ethernet, 10-base-5 Ethernet, which uses coaxial cable as a medium, and also then later the coaxial cables were replaced with the twisted pair fiber optic links. All that you have studied in the theories. And also about the data rate was periodically increased from the 10 megabits per second to 100 gigabits per second. So systems communicating over the internet divide a stream of data into shorter pieces, which are called as frames. So here the frame contains source and the destination address, error checking data, so that the damaged data can be detected and retransmitted. As per OSI model, Ethernet provides services up to and including the data link layer. Now, here in the case of the congestion control or congestion window. So here, to control the number of segments to transmit, TCP uses congestion window, which is CWND variable, whose size is controlled by the congestion situation in the network. Actually, the size of the send window is controlled by the receiver using the value of receiver window, which is advertised in each segment. But use of this, it guarantees that receive window is never overflowed because there is no end congestion. But intermediate buffers in the routers do not become congested. Routers may receive data from more than one sender. No matter how large the buffers of the router may be, it may be overwhelmed with the data, which results in dropping off some segments sent by the specific TCP sender. So, there may be congestion in the middle. More segment loss means resending the same segments again results in worsening the congestion and finally collapse of the communication. So here the TCP is an end-to-end protocol that uses the services of IP. So here, this transmission control protocol needs to define the policies that accelerate the data transmission when there is no congestion and decelerate the transmission when the congestion is detected. So to control the number of segments to transmit, TCP uses a variable known as congestion window, whose size is controlled by the congestion situation in the network. So to detect, actually the window size will be the minimum of receiver window and the congestion window, and to detect congestion, TCP sender uses occurrence of two events, which are timeout and receiving 3 duplicate acknowledgement. That means receiving altogether 4 acknowledgements with the same acknowledgement number. Timeout, which is already you have seen, if the TCP sender does not receive an acknowledgement for the segment before the timeout, it assumes that the corresponding segment lost due to congestion. And sending the 3 duplicate acknowledgement by TCP receives is a sign of missing segment, means one segment is missing but 3 segments have been received. TCP version, that is Reno TCP and the Vegas TCP, which will be adding here as the multiple traffic, treats these two signs differently. So TCP's general policy for handling the congestion is, you can see it in the finite state machine here. There is a slow start, congestion avoidance and the fast recovery. So slow start, there is exponential increase. So size of the congestion window starts with 1 MSS, that is maximum segment size, but increases 1 MSS each time an acknowledgement receives. As we have seen here in the figure, first initially the sender window size is made 1, and also you can see it here with respect to the Reno TCP. Then Ignoring the delayed acknowledgement, first sender starts with the 1. Sender can send only one segment. After the first acknowledgement arrives, acknowledgement is purged, size of the congestion window increases by 1. Because the arrival of the acknowledge is a good sign that there is no congestion, size is increased to 2. After sending the 2 segments and receiving 2 individual acknowledgements, size of the congestion window becomes 4. That is, after 3 RTT, congestion window will be congestion window plus 4, and this continues. To stop, there must be a threshold. The sender keeps track of the variable called as SS threshold, which is slow start threshold. When size of the window reaches the threshold, the slow start stops and the next phase starts, which is said to be the congestion avoidance. To avoid the congestion before it happens, we must slow down this exponential growth. So the congestion avoidance increases additively. Here each time, whole window of the segment is acknowledged, size of the congestion window is increased by 1. So the congestion window is equal to congestion window plus 1 by congestion window. So with respect to the earlier slow start, here after 3 RTT, congestion window will be I plus 3. Next phase is the fast recovery, which starts when 3 duplicate acknowledgements arrive, which is interpreted as light congestion, which is additive increase. Increase in the size of the congestion window when duplicate acknowledgement arrives. If duplicate acknowledgement arrives, congestion window will be congestion window plus 1 by congestion window. So this Reno TCP version, if a timeout occurs, TCP moves to slow start state. If 3 duplicate acknowledgement arrives, TCP moves to fast recovery state. So this fast recovery state is between the slow start and the congestion avoidance. It behaves like slow start, in which the congestion window grows exponentially, but congestion window starts with S threshold plus 3. When TCP enters the fast recovery state, here you can see there can be 3 major events. If duplicate acknowledgement, which you can see to the left side here, if there is a duplicate, here you can see below, duplicate acknowledgement continue to arrive, TCP stays in the same fast recovery state, but the congestion window grows exponentially. If a timeout occurs, you can see to the left side, moves to slow start, which is a real congestion, and here the S threshold will be made as congestion window divided by 2. And if a non-duplicate acknowledgement arrives, TCP moves to congestion avoidance state, but deflates the size of the congestion window to S threshold value. Congestion window will be S threshold value, as though 3 duplicate acknowledgements have not occurred, and the transition is from slow start to the congestion avoidance state. So this is about the Reno TCP. So this uses this Reno TCP, which is a central TCP mechanism where we'll be adjusting the window size. Smaller window size means fewer packets are out, and the less traffic means less congestion. And TCP congestion management is window based, so it adjusts the window size. And congestion window, which is CWND, is the sender's flow control, which is based on the network capacity and the condition, and it is referred in multiples of maximum segment size, which is MSS. So here in the TCP Reno uses a cliff-based strategy. Packets must be lost before the sender reduces the window size, and it does slowly increases the window size if no losses. And on the theory that maximum available throughput may not have been reached, rapidly decreases the window size, otherwise that if losses occur, then drastic action is needed. Next version that we'll be using in the lab is TCP Vegas. This is different from Reno is that it detects the congestion at an incipient stage, which is at the initial stage, based on increasing the round trip time value of the packets in connection, unlike other flavors. It can detect congestion only after it has actually happened via packet loss, which you have seen in Reno. Reno can detect congestion only after it has happened via packet loss, but TCP Vegas detects the congestion at the initial state. So now here let us move on to the programming steps. These are the programming steps already we have seen in the program 1, 2 and 3. Similarly, first we have to start with the scenario Java minus JAR NSG 2.1.JAR. Then we'll be moving on to the wired scenario window, and later we'll be drawing the network diagram. The code gets generated. Once the code gets generated, we have to edit that here. Here we have extra trace file, that is congestion window 2 trace files we want for the TCP Reno as well as for the TCP Vegas. And once we have the congestion window, we have to add few more instructions like giving the color, because there are two different variants, so that in the network animator window, which will be you can see different colors, and also we have to set that congestion window trace file. All these instructions have to be added extra. Once it is added, save, then it will be simulated by using NS. Then we have to have a trace file generated. Once we perform NS, trace file and the NAM file gets generated. You can see in the same folder. Once it is generated, we have to we can edit it. Similarly here, by using the awk code, we have to write to calculate the congestion window, just to display the congestion window. And also here, by using the instruction awk -f filename.awk congestion window 1.tr, which will be redirecting into a file out4a. Similarly, the second trace file generated will be redirecting into out4b. Here these trace files, window 1 and window 2 has got a different format, which we'll see it later. And in the awk file, we write it only to print the throughput. So we are copying it into a file where there will be only time and the congestion window, that is in maximum segment size. We'll be storing it in a file just because, so that we have to plot a graph here. If it is on the terminal window itself, we cannot access those files and plot the graph. So we'll be storing it in a file, then we'll be plotting the graph. This is about the steps. So let us move here to the terminal window. So first, as we have seen for the programs, first we have to start with Java. If it is already typed, you will have these commands: Java -jar nsg 2.1.jar. Once we do this, a window opens where we have to click new wired scenario. So the first 4 programs are wired scenarios. Place the node. So now for the network diagram here, we will be implementing a Ethernet LAN using n nodes, and here we consider those n nodes. LAN part, we are using 6 nodes, and since we have to assign your multiple traffic to the nodes, we'll be assigning the traffic from 2 different nodes at the input side, as we have done it in the earlier program. So TCP Reno is given at one source and TCP Vegas is given at the other source. So we'll have 2 nodes which are the input side, then that traffic is combined and then it is given to the Ethernet LAN. Here the Ethernet LAN, we don't connect it using the link. We write make LAN command once the code gets generated, that is in the TCL script, tool command language script. Now let us start N0. So this N0 where we'll be giving the TCP Reno traffic, N1 where we'll be giving the TCP Vegas traffic, and N2 where we'll be giving the combining those traffics, then it is made to flow through the LAN, Ethernet LAN. So N3, N4, N5, N6, N7, N8. This constitutes the Ethernet LAN. So only till it reaches the Ethernet LAN, we have to connect it by the link. So N0 to N2, N1 to N1 to N2, and also N2 to N3. So these N3, N4, N5, N6, N7, N8, we will be connecting it by using the Ethernet LAN, just by using the make LAN command in the code. Next is about the agent. Here we have to use variants of TCP for the congestion window. One is TCP Reno we'll be using, and there is the TCP Vegas. Already it was discussed about the TCP Reno, so it will be connected to N0, and also TCP Vegas will be connected to M1. Next we have TCP sync, which is connected to the Ethernet LAN any of the nodes. So the traffic will be moved from this source to these destinations. Connected TCP as well as this TCP. Next we have to click on application and connect the FTP. So even here FTP is connected. Next is the parameters. In the parameters we can give the name, save it using 4 dot and also out nam file also we can save it using 4 dot nam file, then save it. Done. Next is TCL. Once you click on TCL code gets generated. Here you can see, as we have already seen, first is simulation parameters, which tells that the simulation window is of 10 millisecond, creating the NS simulator, opening the trace file, opening the NAM file, and also these are the nodes that we have defined, N0, N1, N2, N3, N4, N5, N6, N7, N8. Then it is creating the links. Here we have to change the bandwidth and the queue limit, and also we have the node definition. This tells about how they are arranged here, since we have connected only till N3 node. Next is about the agent definition. Here it is TCP Reno and the TCP Vegas. Though in the network diagram when we draw, it gives the name as only TCP NOT and TCP1. Once the code gets generated, you will get this as TCP Reno and TCP Vegas in the comment. Then it is the application definition. Here we will be changing the time, and then it is the termination code. You save it in your folder wherever it is, with the click it and with the name 4.tcl. So save it. Once after it is saved, you can close this window or you can minimize. Afterwards you can access this using the command on the terminal window. So in the control C, first move inside your folder, that is CD, with your file name. Only then you can access you can use other commands. Then you can open your file gedit and you can make the changes here, or you can make the changes there itself. So now I have already made those changes. I'll tell you which are those. One is, since there are two variants of TCP we use, we'll be giving colors to those for TCP Reno as well as TCP Vegas. Just in that, so that in the NAM window we'll get it with two different colors. Next is with respect to the nodes. Here you can change these bandwidths here, and also the queue limit, 2 MB, 2 MB, 1 MB, all that I have done. And also for the LAN part, we don't connect it using the link, so we use a make LAN command. Remember this properly, make LAN. Then we write for which the LAN has to be connected, 3, 4, 5, 6, 7, 8. Then we write the bandwidth. And also in the TCP Reno, once the code gets generated, we have to type these extra codes. One is to set class _1. This just assigns that color 1 to this TCP Reno. So if the color 1 is blue, then that blue color will be applied to that packet. Then we have to have set tfile1 open congestion window 1.tr for writing. So this is done to open that congestion window file inside your folder. When you type ns along with the 4.tr, which is a trace file of the program, and 4.nam file, which is network animated file of the program, we will have congestion window 1.tr as well as congestion window 2.tr file which gets generated, which has to be attached to TCP NOT, and we have to trace CWND underscore, which is congestion window. Once the congestion window 1 file gets generated, I'll show you later. Similarly, in the TCP Vegas, similar instructions will be adding, and these instructions are similar to the one as we have set trace file. Here it is, these are set to be T files, set T file. Then application, here change the time 1 to 8 so that you can see the packet transmission from 1 millisecond till 8 millisecond, and similarly for the FTP over TCP Vegas. So next is, once this is done, we will be moving to the next part, that is you can close this, then we will be you can open it by using the terminal window later. Next we will be moving on to the terminal window. Once we have the code, we have saved that code. Now move on to the terminal window. So here in the terminal window, press Ctrl C to get the command prompt. Since you are inside your folder, next is you have to have ns file. So type ns and the program name .tcl. So once you do this, you will get the NAM window. So it is said to be the network animator window, which you can see here. So 0, 1, 2, 3. If you play this, you can see the packets flowing. You can drag this. You can see here these are the TCP. Two different colors are given. Since I have given the bandwidth in megabits, you can see the flow will be little faster, and it is flowed to the Ethernet LAN. This you have to run it till the end. It reaches till 10 milliseconds. Once it is done, minimize it. Move back to the terminal window. Once again, move back to the terminal window. Press Ctrl C. So here what you have to do is, once the NS is performed, if you go to your folder, I had accessed here in the home Jovita folder, you can see that you will have, along with the 4.tr file, you will have 4.nam, 4.tcl. so these are the two more files, 4.tr, 4.nam. we had only 4.tcl saved. So whenever you perform ns, with this trace and the nam file will be created, and we had given this name in the parameter in the first step. And also along with that, we will have the file of congestion window 1 and congestion window 2. So with respect to 4.tr, this is a trace file. Already we have seen. First will be the event. It can be plus, minus, r or d. Similarly, second will be the time, then is from node to node, then it is the packet type, and then we have the packet length. This is what about the trace file is. And also we can see the congestion window file. So this is the congestion window 1.tr, you can see here. So in the congestion window file also we will have the time from node to node. In addition to that, we have last in the $1, 2, 3, 4, 5, 6, 7, $7 we'll have the congestion window values, which is maximum segment size. And similarly we'll have congestion window 2 generated with the same. So one is of TCP Reno and the other is of TCP Vegas. Next is, once it is done, we have to type the awk file. So gedit, I have already typed it. Otherwise, once you type the blank awk file, you'll have to type it here. Now it is with the begin. Nothing has to be initialized here, nothing has to be printed onto the terminal window. Only if you want to print something on the terminal window, you have to write it in the end. Now since we have to have the printing, which should be in the loop, in a continuous process, we include it in the loop part here. And in the printf here, if there is a $6, this is with respect to the congestion window trace file. Till now in the program 1, program 2, program 3, we will be writing it with respect to the trace files of the program. Here it is with respect to the congestion window trace file, we write the awk code. So congestion window, wherever we have, that has to be printed along with the time. So congestion window value and the $1, which is the time value, where this has to be printed in a file, because we will be redirecting that to a file, because it is in the loop. Otherwise, if we don't redirect into a file, it gets everything printed onto the terminal window itself, since it is in the loop. If you write it inside end, only it gets printed once, only the last value of the congestion window and the time. So now let us move on to the terminal window. So once you have gedit, now we have to use awk -f. It is to post analyze post trace analysis, so which is done using 4.awk space. Then we have to write congestion window cwnd 1.tr, and which is redirected to out 4a. Similarly, we have to do awk -f 4.awk cwnd 2.tr, which will be directed to out 4b. Once it is done, you'll have out 4a and out 4b, two files created in the same folder. So you can see here, this is out 4a, where you will have the time, and here is the congestion window values. Similarly, this is of out 4b, the time and the congestion window values. So you can see here, with respect to the TCP Vegas also, congestion window keeps increasing here, and once it reaches some value threshold, once again it starts to decrease, then it will increase. Once it reaches a threshold, once again it starts to decrease, as I have explained you the theory part. So it will avoid the congestion at the incipient stage. If you consider incipient stage, if you consider congestion window 1 also, you can see here, it will not consider at the incipient stage. Once it gets the loss, for example 20, when it reaches, congestion window is made as 10, then it is, when it reaches 10, if there is a congestion occurs, a packet loss, it will go to congestion window will be go to one state. So this is with respect to the slow start, congestion avoidance, and the fast recovery states. So once that is done, now the next is we have to plot it in the xgraph. So use xgraph command with out 4a file and out 4b. If you type so much, you will get the output, but still to look better, you can use the geometry, you can use a title to it, background, all that can be done by using the instructions. So here just we'll do first out 4a, out 4b. Let's see what happens. We'll get our graph. So in this graph you can see that red stands for 4a, which is of TCP Reno. So you can see that it will not detect at the incipient stage. Whenever the congestion window value becomes 20, suddenly it drops down because of the congestion. Next it will drop, and TCP Vegas will detect at the incipient stage, and this is how the congestion is avoided. Now to look better, you can have the titles given. Instead of xy you can give name, instead of xgraph we can give the title. All that can be done. Just like after xgraph out 4a, out 4b, you have to write a minus. Background can be changed to other color. I'll write here white. Then you can give a title -t, and you can give it as maybe congestion window or something like that, anything. Congestion window as the title. Similarly, x-axis you can give it as in the inverted commas, maybe x-axis is the time, you can give round trip time, and also -y, you can use the y-axis as the congestion window, that is CWND. So this is how it is done. So you will have in the graph, congestion window is the title, then RTT is x-axis, CWND is the y-axis, and this is what the graph is. So that is how the congestion window will be obtained. So so because of this, the learning outcome of this program is that we have got the knowledge about Ethernet LAN, which we had done it in the program 3 also, and also a variation of the congestion when the bandwidth queue size are varied is noticed here. You can perform this by varying the bandwidth value in the TCL script. Wherever we have the links, we can observe the congestion, and also see we can notice that by using the variants of TCP, that is TCP Reno and the TCP Vegas, we can avoid the congestion in the network. Thank you.